This tutorial is going to be about Pythagorean identities and simplifying trig expressions. So this is our new unit, and Pythagorean identities are three different identities that are going to be really important when it comes to simplifying expressions. So you can see over here I have a quarter of the unit circle. So it says, how could you write the Pythagorean theorem for a triangle formed in the unit circle below? So if it's the unit circle, when we know that the radius of the circle is 1, and since this is the point xy, I know that this leg of the right triangle is going to be x units long, and this leg is going to be y units long. So the Pythagorean theorem tells us that we would say x squared plus y squared equals 1 squared, which would be 1. Now this should look familiar. This is the formula that we wrote for the equation of the unit circle, centered at the origin with a radius of 1. This is what you would type in, for instance, if you were graphing it on Desmos. So how does this help us? Well, how could we substitute trig functions into this equation? Think about what we know about any terminal point. So if I'm talking about on the unit circle, let's say I'm at pi over 6. So if this is the angle pi over 6, then it has the terminal point root 3 over 2 and 1/2. And I know that if I say, what's the cosine of pi over 6? Well, our answer is going to be the x coordinate, root 3 over 2. And if I say, what's the sine of pi over 6? That's going to be the y coordinate, which is 1/2. So our x value is the cosine of this angle, in this case theta, and the y is the sine of angle theta. So we could substitute x with cosine of theta. So x squared is going to be cosine squared of theta, plus y squared is sine squared of theta equals 1. Keep in mind I put the squared with the trig function. It's not the cosine of theta squared. It's the trig function being squared, not the angle. This is your first Pythagorean identity. It's going to be the one that you probably reference the most, and it's the one that we're going to utilize to actually come up with the other two. So let's say if you're on a quiz or a test, you're going to be asked to use all three of them. As long as you know this one, you're going to be okay because you're going to be able to calculate the other two as well. So in the next part of your paper, it says, now let's use this Pythagorean identity to derive the other two. I'm going to just kind of split this, and I'm actually going to rewrite it. So cosine squared of theta plus sine squared of theta equals 1. I'm going to rewrite it twice because we are going to utilize this to come up with the other two. So what you're going to do to come up with the other two is on one of these, you're going to divide both sides by cosine squared. And on the other one, you're going to divide both sides by sine squared. So as long as whatever you do to one side, you do it to the other, that's allowed. So if I divide this side by cosine squared of theta and this side by cosine squared of theta, let's think about what that would give us. Cosine squared over cosine squared is going to be 1 plus sine squared of theta over cosine squared of theta. We know sine over cosine is tangent, so this is going to be tangent squared of theta equals 1 over cosine squared is secant squared. So this right here, this is your second Pythagorean identity. The third one, we're going to do the same way, except instead of dividing by cosine squared, we will divide by sine squared. So if I divide both sides by sine squared of theta, cosine squared over sine squared is going to be cotangent squared of theta, plus sine squared over itself is 1, equals 1 over sine squared is cosecant squared. So this is your third Pythagorean identity. So I'm just going to write them all in this box. This is really just for you so that it's in one quick spot for you to reference anytime that you need it. So we know cosine squared plus sine squared equals 1. And then again, if you divided everything by cosine squared over cosine squared is 1, plus sine squared over cosine squared is tangent squared equals 1 over cosine squared, which is secant squared. So there's your second one. And then again, from the beginning, if we divided everything by sine squared, we would get cotangent squared of theta plus 1 equals cosecant squared of theta. Now, one thing I want to point out is this statement right here, sine of theta plus cosine of theta equals 1. Notice that this is not the same as what we have here. Here we have cosine squared plus sine squared equals 1, whereas here it's just sine plus cosine equals 1. We know that this is going to be false. Think about, again, let's think about pi over 6. If I said sine of theta, so sine of pi over 6, well, I know that's 1/2, plus cosine of pi over 6 is root 3 over 2. That's not going to equal 1. However, like our Pythagorean identity says, if we were to square both of these, then it would equal 1, right? 1/2 squared is 1/2 times a half, which is a fourth, plus root 3 over 2 squared is root 3 over 2 times root 3 over 2, which is 3/4. That does, in fact, equal 1. So it's only going to be true when it looks like this. Sine squared plus cosine squared equals 1. So in the next video, I'm going to show you how to apply these.